Teledyne Ryan Aeronautical is a company of aerospace firsts. Teledyne Ryan Aeronautical is a company of capabilities. The Teledyne Ryan Aeronautical main plant, located on a 44-acre site adjacent to San Diego International Airport. The main plant is a central production facility for prime or subcontract aerospace manufacturing, while 15 minutes to the northeast, the Kearny Mesa Electronics and Space Systems Center produces a full line of Doppler radar systems for surface and aircraft navigation, as well as spacecraft soft landings on the moon and other planets. In the early 20s, flight was still in its infancy when T. Claude Ryan founded the Ryan Aeronautical Company and later accepted the challenge of building Charles Lindbergh's Spirit of St. Louis, a great technological achievement in its day. Throughout the following half-century of aerospace progress, Ryan became known for many firsts in the industry, such as vertical takeoff and landing, pilotless jet target drones, and the first and only lunar landing radars. In 1969, the company became Teledyne Ryan Aeronautical, a wholly owned subsidiary of Teledyne Industries of Los Angeles. Teledyne Ryan Aeronautical supplies nearly every defense system in the free world with Firebee jet target aircraft. Firebee-1 is a subsonic descendant of over 25 years of jet target experience and development. In its basic configuration, Firebee-1 is a workhorse in defensive weapons training for the Army, Navy, and Air Force. Firebee's performance envelope includes a maximum speed of Mach 0.97 in level flight, altitudes from 50 feet to 60,000 feet, and endurance of 115 minutes in flight. Firebee's highly modular design can incorporate a variety of missions or provide a wide spectrum of realistic target simulation through radar augmentation, chaff dispensing, and infrared augmentation, plus various aerodynamic performance modifications up to an 8G capability. Supersonic threat simulation is the realm of Firebee-2. Longer, leaner, shorter wings than its predecessors, this high-performance remotely piloted jet target attains speeds, altitudes, and G maneuvers that put present-day weapon systems to the test. Firebee-2's performance envelope includes altitudes of 50 feet to 60,000 feet and speeds to Mach 1.8 with future growth potential of 75,000-foot altitudes and speeds of Mach 2.5. Launched and recovered the same as Firebee-1, the supersonic Firebee can also provide a wide number of radar cross-section and infrared signature. Firebee-2's modular design can be tailored for specific mission requirements or updated to meet future needs. In addition to providing the most realistic targets available, Teledyne Ryan manufactures an entire family of special-purpose remotely piloted vehicles. They range from low, medium, and high-altitude photographic reconnaissance vehicles used extensively in Southeast Asia to medium to high-altitude signal intelligence gathering and passive-active electronic countermeasure vehicles. These RPVs are capable of being flown manually or by a pre-programmed, internally controlled system and have mid-air or surface recovery potential. The AQM-34M, for example, is a low-altitude reconnaissance vehicle featuring radar altimeter control equipment, wing hardpoints for external stores or fuel pods, and a highly accurate navigation system. Another RPV capability is weapons delivery, a most valuable asset in extremely high-risk areas. The BGM-34B has successfully delivered on target the SPASM, a heat-seeking self-propelled air-to-surface munition, as well as the stubby Hobos television-guided glide bomb, and the Maverick television-guided missile. The BGM-34C is a systems approach to the integration of reconnaissance, electronic warfare, and strike drone applications. The snap-on nose modules and single airframe provide the versatility and economies of standardized production. BGM-34C is a cost-effective way of hitting priority targets, securing high-quality reconnaissance, or providing tactical electronic weapons support without risk to air crews. One of the most unique, remotely piloted vehicles developed by Teledyne Ryan is the Mini RPV. Designed for a broad spectrum of missions, the Mini RPV performs target acquisition and designation, surveillance, reconnaissance, weapons delivery, and intelligence gathering. Real-time television coverage with location coordinates transmitted simultaneously is a high-priority mission. One of the latest developments in high-altitude, long-endurance RPV technology is Compass Cope. Cope is designed for runway takeoff and landing, either manually or fully automatic through an onboard computer, radar altimeter, and TALAR, Tactical Landing Radar System. With an 81-foot wingspan, turbofan engine, and flight endurance in excess of 24 hours, Compass Cope is designed for high-altitude peripheral reconnaissance, battlefield ocean surveillance, and relay missions, with sufficient redundant systems to assure the required mission reliability. Much of the electronic equipment aboard Teledyne Ryan Aerospace products, as well as those of other leading aerospace manufacturers, is designed and produced by Teledyne Ryan Electronics, which is responsible for developing and building extraterrestrial landing radars and altimeters that have guided every U.S. lunar vehicle to a soft moon landing, including all manned spacecraft landings. The Viking spaceflight to Mars called for a Teledyne Ryan terminal descent and landing radar and specially designed radar altimeters to withstand the rigorous Martian environment. The radar altimeter provides readings from 235,000 feet down to 100 feet, the greatest altitude range of any altimeter built in the United States. The landing radar provides velocity data from 20,000 feet to 5 feet through the critical touchdown phase. As well known as Teledyne Ryan Electronics is in the field of aerospace landing radars and altimeters, it is equally known as one of the world's largest producers of airborne Doppler radars and navigation systems, such as the AN/ASN-128 Lightweight Doppler Navigation System, known as LDNS, specifically designed for rotary wing aircraft, where size, weight, and low cost are extremely critical factors. Composed of a Doppler radar velocity sensor and control display unit, the LDNS generates latitude, longitude, and other navigation coordinates, as well as steering data to a pilot-selected flight path. The Teledyne Ryan AN/APN-200 and the AN/APN-213 velocity sensors are lightweight Doppler radars that provide data for accurate point-to-point navigation. In the Navy's S-3A aircraft, the AN/APN-200 pinpoints the location of enemy submarines hidden beneath the ocean's surface. The AN/APN-213 is specified in the U.S. Air Force AWACS and B-1 bomber flight test vehicle application. Both units are similar in design with the exception of a self-contained blower in the AN/APN 213, while the AN/APN 200 uses available aircraft air for cooling. The AN/APN 182 is a Doppler radar navigation unit currently in production for Navy anti-submarine warfare, search air rescue, and the light airborne multi-purpose system known as the LAMPS helicopter. The AN/APN 182 is a 3-beam continuous wave radar with velocity measurement capability from motionless hover at altitudes of 6 inches to 300 knots ground speed at altitudes up to 20,000 feet. Teledyne Ryan's latest airborne navigation system specified for the LAMPS helicopter is the AN/APN 205, an all-solid-state, micro-miniaturized, lightweight, fixed antenna system. Teledyne Ryan also manufactures special-purpose radars, such as the Model 622 terrain-following radar for helicopters and light fixed-wing aircraft, where size, weight, and cost are critical factors. Model 622 TFR provides the pilot with indications of altitude and climb-descend commands based on a measurement of terrain obstacles in the aircraft's flight path within a 1.5-mile range. The 622 TFR weighs less than 20 pounds, requires 1/2 cubic foot of space, and interfaces with other avionics equipment and autopilot. Teledyne Ryan's role as an aerospace manufacturer is a matter of record. To date, over 5,500 Firebee jet target drones have been produced on a prime contract basis, as well as subcontract production, such as the AAH helicopter fuselage for Hughes helicopters. Teledyne Ryan's manufacturing capabilities are one of the most comprehensive in the aerospace industry. Numerically controlled machining as well as conventional machining, tool design and fabrication, welding and brazing, metal processing, metal forming, non-metallic fabrication and adhesive bonding, and assembly. All part of a total engineering, design, and manufacturing capability. Teledyne Ryan's success in the field of aerospace is due in a large part to its long reputation for reliability, responsiveness, and pioneering spirit. These qualities continue in Teledyne Ryan Aeronautical's approach to servicing the aerospace and electronic needs of the world and beyond. Teledyne Ryan Aeronautical is a company of capability.